Compressible flow tutorial number 5. Explain why the Bernoulli equation cannot be accurately used for compressible flow. And for the other question, we have air flows isentropically through a converging diverging nozzle. At a section in the converging section, A1 equals 0.1 meter square, P1 equals 600 kilopascal absolute, T1 equal 20 degrees Celsius, and Mach number 1 is equal 0.6. For section 2, in the diverging part of the nozzle, determine A2, P2, and T2 if Mach number at point 2 is 3.0. So to answer this question, you need to remember all these 4 basic equations for isentropic flow. So you need to remember the T2 over T1, P2 over P1, rho 2 over rho 1, and A1 over A2. So it is okay for you to derive your own equation for this one because it is come from the mass flow rate rho A and V. So I already explained how to get this equation in previous lesson. Next, you need to imagine what is convergent and divergent nozzle. So usually you could draw like this, and then you could say that this is point number 1 at the converging section, and this is point 2 at the diverging section. Then you need to determine what is the medium. In this question, the medium is an air, so we use K equal to 1.4. This is a constant for air. If the medium is different gas, for example hydrogen, nitrogen, and so on and so forth, you need to use a specifically K for those gas. Then please list down all the parameters that you get from the question. For example, at point 1, which is the converging section, we know that the M1 is equal 0.6, A1 0.1 meter square, T1 is 20 degrees Celsius, and P1 is 600 kilopascal absolute. And then at point 2, from the question, we know that the Mach number 2 here is 3.0, and we need to calculate what is A2, T2, and P2. So what you need to do is to get an A2 here, so you need to substitute all the data in this equation, and finally you could find the value of A2 here. The answer is 0.2806 meter square. And to get the P2 here, pressure, so use equation for pressure here. So we substitute the value of P1, Mach number 1, and Mach number 2. We use K is equal 1.4, and finally we could get P is 20.83 kilopascal absolute. And then to get the value of T here, we will use the equation for temperature here. We substitute all the values, and then please bear in mind that you need to change the unit here from degree Celsius into Kelvin. So when you solve that calculation, you will get T2 is equal to 112.17 Kelvin. And then why Bernoulli equation cannot solve compressible flow? Because at high Mach number, compressibility effect is significant in the Bernoulli equation. So significant means that the compressibility effects mean the density will change, means that it will ruin the calculation of Bernoulli equation. So Bernoulli equation can only be used for low Mach number, and usually we take Mach number 0.3 is the limit. More than Mach number 0.3 is considered compressible flow, so we need to use compressible flow isentropic flow equation.